Hello one. So far we have studied three different techniques of AM generation. First one is DSB-FC double sideband full carrier system, then DSB-SC system double sideband suppressed carrier, and single sideband suppressed carrier system. And from our discussions we know that DSB-FC system was the least efficient among all, as we were transmitting full carrier along with both the sidebands in this system. And it was observed that this full carrier actually means the transmission of full carrier actually consumes 50% of transmission power. So it has decided to suppress the carrier to avoid this 50% more consumption of power. And this gave birth to new scheme of AM generation, that is DSB-SC. In another terms, we can say that this system is power efficient, means 50% more power efficient than DSB-FC system. But bandwidth of transmission is still the same for both the schemes. I mean, for DSB-FC it is twice of FM. Likewise for DSB-SC we have twice of FM. But later it was realized that USB and LSB, they are uniquely related. Right, that means they are symmetric across this axis, FC axis. And this distance from FC to FC plus 1 is FM. Likewise here it is FM. This becomes twice of FM. As both the sidebands are symmetrical, that means the information contained in both the sidebands is exactly same. So this idea resulted a new modulation technique, AM modulation technique, that is Vsb Sc, in which we are going to transmit only one sideband and will attenuate the another sideband. In this particular spectrum we have upper sideband transmission and the lower sideband is being attenuated, and this we know can be achieved by using band pass filter. Alright, and we know that this filter can be tuned either to upper side frequency or it can be tuned to lower side frequency. If it is lower side frequency, then this sideband will get transmitted and the upper one will get attenuated. And from here we can conclude that the bandwidth reduces to FM only, as we are transmitting this distance only, this information only, right? And this part is being attenuated. So this way we achieved bandwidth efficiency. Alright, or we can say that for Vsb Sc scheme we have achieved both transmission by suppressing the carrier, transmission power efficiency, and bandwidth efficiency by just eliminating one sideband. But still, this Vsb technique further complicates the receiver structure to recover message. Actually, it is an important limitation of Vsb, you can say. This unwanted sideband which we want to suppress lies very close to the wanted sideband, right? So this process becomes quite complicated, because suppressing components of this part may result in damage or eliminating of a portion of this wanted sideband also. And in many cases, or most of the cases, the information, it can start from this point and can range all the way up to FM hertz. That means it spreads all over the sideband. So cutting out or filtering out unwanted sideband may result in damage to some information content, or may result in attenuation of some information content of the wanted sideband. The solution to this problem was made by developing a new technique, that is Vsb Sc Technique, and this is an acronym for Vestigial Sideband Suppressed Carrier System. In this scheme, we transmit a portion, or you can say the vestige or fraction of unwanted sideband along with the wanted sideband. This vestige of unwanted sideband will act as buffer between this unwanted region and this wanted region. Therefore, any losses caused due to filters or due to filtering operation will be caused to this region only, and this information means the wanted sideband remains safe. So mathematically, the vestigial sideband equation becomes this and this. Suppose we are transmitting the upper side frequencies. Alright, as you can see, this is the upper side frequency, Fc plus Fm, and this F basically is representing the vestige of unwanted sideband, that is lower side frequency. Okay, This can be seen in the spectrum diagram, right? This is the upper side frequency and we are transmitting a vestige of lower side frequencies, all right, this portion. Likewise, if we are transmitting lower side frequencies, or we have implemented a band pass filter with a low sideband transmission, then this portion will get transmitted and a vestige of the upper side frequency will have. Okay, this can be shown using this spectrum below. This portion is the lower sideband or lower side frequencies, and we are transmitting this upper side frequency vestige only. Okay, so again, just like SSB, we can have two different equations or two different transmission patterns based on which particular sideband we are going to transmit. Okay, definitely you might be having questions about bandwidth. Obviously, the bandwidth of this transmission is going to increase a bit. Mathematically saying, the bandwidth will become, for suppose this transmission I'm considering, the bandwidth becomes Fc plus Fm, right? This higher frequency minus this one, right? This time Fc is not the lowest one. The lowest frequency is Fc minus Fv. So we'll subtract out this frequency from this one. So this becomes Fc plus Fv, or this Fc gets cancelled out. So I'm left with Fm plus Fv. So that is my new bandwidth. Obviously that is slightly greater than the SSB transmission, but is more efficient in terms of preserving signal or information content. Likewise, you can calculate for lower transmission, lower sideband transmission as well, right? This time higher frequency is this Fc plus Fv, okay, and lowest frequency is Fc minus Fm. So this becomes minus of Fc plus Fm, right? Again, you will be getting the same thing, Fm plus Fv, all right. So far we have discussed all the four AM generation techniques or AM modulation techniques. Number one was a DSB-FC system, then we switched on to DSB-SC, then SSB-SC and Vsb-SC. In upcoming classes we'll be doing the power calculation for all these schemes. Till then, thank you and have a nice day.